Hello friends, welcome to the Edupedia world. In this tutorial, we'll cover the fourth installment of our ongoing tutorial about variable data types and constants. So far we have covered variables, data types, category of data types, declaration of variables, assigning value to variables, assignment operator, scope of variables, standard default values, constant and symbolic constants. In this tutorial, we'll be covering up last and very important topic, that is typecasting. So majorly we are focusing on primitive data type typecasting in this tutorial. So let's begin. Well, we are going to open up the Eclipse and try out some example to see how typecasting actually is performed. I think that would be really helpful. So let's do that. Hi guys. So this is an example of typecasting. We'll see what we have done. So basically, just to tell you what is typecasting, it means casting a variable of one particular data type to another particular data type. Well, we have two type of typecasting. One is called implicit typecasting and other is called explicit typecasting. Okay. So implicit typecasting means in which you do not have to type cast operator, in which there is no cast operator required and the typecasting is done by compiler itself. Whereas we have an explicit typecasting also. In explicit typecasting, the compiler will not automatically typecast it to other compilers, so you need to manually typecast it. Let's see how it is done. Okay, so just imagine you have to cast a int variable to a byte. So this is something where I have written byte b equals to 27. Okay, so over here 27 is a int, but we are storing it in a byte. So do you think it's possible and this code will execute? Well, let's see. For now, I'm just commenting all the below code to able to run this code. Okay, now let's run. Okay, so we have got the output as 27. And how do you think so that is happening? Well, that's because whenever an int is typecasted into a byte, the implicit conversion happens. So implicitly, your compiler will convert 27 into a byte. Okay, and the byte formation is displayed. Now let me change the value of it. So over here I have changed the value of byte of 27 to 227. Here you can see I'm getting a error and my error says add cast to byte, change type of b to int. Okay guys, so the reason I'm getting a error is because now the value 227 is going out of the range, that is minus 128, 2 plus 127, that is defined for the byte. Okay, if I change it to 127 then it will be acceptable, but as soon as I go to 128 it will give me an error. So I hope that's quite clear that byte can take up int value only if it is falling in that particular range. So this is a casting that can be done implicitly. Okay, so now let's see other example. Okay, so in this example, um, let me take the value as 228. Now you see 228 is something that is out of the range of byte. So if I not put this cast operator, it will give me an error. Now in order to fix that error, I need to cast it to byte like this. Once I do it, then it won't give me an error and it will be acceptable. Although the output of this program won't be, simply 228. So let's see what's the output. Well, the output is minus 28. And why is it so? This output is created by converting 228 into a byte form. So this is like a byte output that you are seeing on the screen. I hope that's clear that when to use bytecast and when not to use byte. Okay, so there's a statement which says everything we are saying about byte applies equally to char, short, and both of which are smaller than an int because char and short are also smaller than int. So you can also provide an int value to char and short, but they will only accept these value if it's in a particular range. If it's out of their range, then again you have to put a cast operator for char and short also. So let's see the example of char and short. Okay, and let me comment this one out. Yeah, we are good. Now see, simply I'm putting char equals to 1, I'm printing that, and it's not giving me any error. But if I put a short value that is out of the range of short, then I have to cast it to short. And if the short value, that is the int value that I'm providing, is within the range of short, then it's okay. It won't give you any complaints. So let me run these three statements. Uh, well, you can see in case of a char, it has converted into a Unicode character and it is printing something weird. Whenever we are converting it to a short, then again short. Okay, my mistake. I need to put S over here, not C. So that was the error. Let's run it again. Okay, yeah. So now it's converting this whole value of integer to a short and it's giving me the output as 27603 to put it within a range of short. So that is typecasted. So after conversion of int to a short, this is the value that we are getting for this integer. Okay. And the third one is printing short as it is. So I hope it's clear. So I will just try to state the first rule of typecasting that we have done. So the first rule of the typecasting says that you can convert byte, int, char, and short. I'm sorry, it should be byte, char, and short. Well, the statement that I have written is you can convert int implicitly to byte, char, and short in case if the value of int is within the range of these. Else you need to explicitly cast it. I hope that's clear. So let's move towards another really good example of typecasting and see how it is done. Okay, now this is an interesting one. So let's see this one. Okay, so over here I have taken byte m equals to 3, no problem, where 3 fits into byte. Again I have taken byte n equals to 8, again no problem because 8 fits into byte. Now what I'm doing is I'm taking a byte O and I'm assigning it to m plus n. So I'm doing a addition of m plus n. It should be no problem because 3 plus 8 is 11 and 11 do fit into a byte range. But it's giving me an error. Any idea why so? Well, that's because whenever you add two bytes which are having an integer value, it automatically get incremented to an integer. So whenever you are performing any operator with 2 bytes and assigning it again to a byte, just make sure that you are typecasting it to a byte as per this statement. Okay, because otherwise it will give you a compiler error. And the error that it will give you, so over here it's giving me an option, either I have to cast it into a byte or I have to change the type of O to int, because it is producing an int result. And if I still try to run this code, then it's giving me an error, type mismatch, cannot convert from int to byte. So I hope now it's pretty clear to you, this rule. So just to write it down, I'm going to say whenever you put any operator, or rather an arithmetic operator with 2 bytes and store it to another byte, make sure that you are typecasting it to byte, else it will give you a compiler error saying mismatch types cannot convert into a byte. Okay, I hope this is quite clear. So now we are moving to next example. Okay, so this one is a small example. Okay, let's see here. So over here I'm taking int in equals to 100, and then I'm taking int lo equals to in. So over here what I'm doing is I'm assigning a int value to long. So that's perfectly fine. Why so? Because the range of long is very bigger than the range of int. So long can include each and every value that a int can hold. So over here we are having a implicit cast, and int value always fits in a long. So I hope it's clear. For like a long, the int value will fit into it. Similarly goes for short. Okay. So let's see a short example also. Um, Over here I'm declaring a short short is equals to 12. Okay. And let's see if the long is taking up the short value. Well, it is. It's not giving us any error. And let's try same for byte. Okay, again it's not giving us any error. So long can take up int value, byte value, and short value implicitly. Let's see if char is possible. Okay. Oh wow, char is also possible. So that means any you can say data type that is having a higher range can take up the values of a shorter range. So it's something like you are having a big box and you can fit small box into it, but a small box cannot fit a bigger box into it. Fine. So that is how the rules go. So implicit cast can be done in like long can hold a value of int, char, short, and byte. I hope that's quite clear. Then let's look another example which is quite different from this. Okay, so over here we are doing a explicit cast, and what is it? So we have defined a float value fo, and the value we have given is 100.001 f. And then we are doing a explicit cast because we are putting this fo, that is the float value, into int. Why is it so? Because obviously float has a higher range than int, and int cannot hold the value of a float because the int value cannot contain decimals. So whenever you try to do that, you will either get a problem with the compiler. So let's try doing that. Okay, see, it's giving me a compiler error, and it says like you cannot do that, you have to cast it. So I'm casting this one to int. Now it's perfectly fine. You can cast a float to int explicitly, but by doing so it will definitely lose precision. So the output that you will see on the screen will be 100, not 100.00f, because we have converted it into a int. So let me show you the output as well. Okay, so for that I need to put a SOP statement to print the value of in2. So yeah, it's got a pretty hang, so let's wait for a second. Yeah, it's fine now. Now I'm running my code and let's see the value. Yeah, so you can look, the value of in2 is 100. It has casted float to integer by removing its precision values, the decimal values. Fine. Okay. Let's check this example. In this example, we are putting a long value into a double value where it's an implicit cast. You can do that because double can take up long values because their range are pretty much same. So double can hold a long value. Well, can we do a vice versa? So let's try to do that. Let me have the double value as something like that. And let me try to put it into a long variable. Well, you can see over here, it's saying me to cast it into a long. Why so? Because although the range of long and double is, the memory that long and double takes is quite equal, but your long value cannot contain decimal points. So if we are doing to do that, it will definitely give you an error. So you need to cast it into a long. Okay. Now let me just run it and okay, I haven't placed a like SOP statement right now, but yeah, if you do so, you will get the value as 100 because it will remove all the decimal points. Okay, so what we have stated that for converting long value to double, it's possible using an implicitly cast because you don't have to cast it explicitly. But if you are converting a double value into a long, then you need to explicitly cast it, okay, by putting an explicit long. I hope that's quite clear. Okay, now let me comment this out and let me uncomment below example and see what it says. Okay, so in this example, I'm trying to put a float value into a integer value. So as we have seen before that this thing will give me an error because int cannot contain decimal points. It's out of its range. So I need to pass it into a int. So if I do that, it's okay. It's not giving me a compiler error. Okay. Let's see this example. In this example, what I have done is Um, okay, so I have cast it now this to a int and now I'm printing it. So what do you think will be the output? Well, as we have seen earlier, I think it should remove your decimal points. Yeah, so it did that. It's just printing 3957 by removing 0.229. So I hope that's pretty clear. That was a very simple example. So let's move forward with another example. Okay, what's up here? Fine. So in this example, we are taking up a long variable and assigning it 130L, perfectly fine. We are assigning a long value to a long variable. Then we are having a byte variable and we are assigning it to we are assigning a long variable to a byte variable. So over here you need to typecast it because a byte cannot contain a long value because long is like really huge for it. So what do you think will be the output for it? Let's run and see. Okay, so it's saying the byte is minus 126 because it has converted the long value to byte. I hope that is also quite clear because you need to explicitly convert whenever you are typecasting bigger range or a bigger value to smaller box. So it is something like long is a big box and byte is a small box. You cannot put a big box into a small box directly. So you need to typecast it. Fine. So, okay. We have something over here. Let's see what is it. Mm, okay. So over here again, like I'm having a float value and I'm putting it in a short, then I need to explicitly cast it. Fine. So yeah, that can be done easily. Let's move forward now. I think that example was quite simple and yeah, moving forward now. Okay, so let's see some of the float example. So we have declared a float f equals to 3.23. Well, it's giving me an error. Why so? Because in Java with float, you have to always put f after putting the float value. So, you cannot declare it like that. In order to declare it correctly, you have to put f over here. So now it's not giving me an error. So the reason is that you need to put f over here. Well, what about this? Well, over here I haven't placed a f. If you don't want to do that, then you can also typecast this value to a float. Okay. So in case of floating literal, first you must know that every floating point literal is implicitly a double. So if you are not putting f, then it will take it as a double and it cannot store a double value to float. Okay, so literal 32.3, for example, is considered a double. If you try to assign a double to a float, the compiler knows you don't have enough room in 32-bit float container to hold a precision of a 64-bit double, and it will let you know by giving it an error. Okay, so that's the reason that you need to put either f over here or you need to cast it into a float. So that was an interesting point. Okay. Now let's move forward and check out the last example of this tutorial. Okay, let me do this. Okay, so over here I have taken byte w equals to 3, and then what I'm doing is w plus equals to 7. So over here it's not giving me any problem. Why so? Because although I'm applying a arithmetic operator as we have seen in our previous example, but I'm not applying plus arithmetic operator. I'm applying plus equals to. So what this operator does it implicitly do the byte conversion. So over here it's not converting into a int. Well, I would rather say it's converting it to a int and it is implicitly then converting it again to a byte. So you don't have to explicitly put the byte cast, and this is perfectly legal, and the result that you will get would be 10. Well, if you see it, it is equivalent to something like that, where we have created a variable byte q equals to 3, and then we are doing q equals to, and then we are casting it to a byte by doing q plus 7. Okay. Um, so this is absolutely fine, but just to reduce the code, you can simply do this. So internally, this line is actually doing this thing. So I hope it's very clear. So that were the typecasting example. So overall, I hope so that you have got all the rules of typecasting. It was quite simple to understand, and yeah, you can try it yourself by doing some of the examples of typecasting. Okay guys, so thank you for now. So this was the end of tutorial where we are learning variable constants and typecasting. And now we'll study something else in the next tutorial. So thank you.